Hello and welcome again. This is week 2, lecture 8, and today we will be discussing about the prehab exercise design, which includes the range of motion, muscular strength, and neuromuscular control. The objectives of today's lecture are to define and understand the concepts of range of motion, muscle strength, and neuromuscular control in knee prehab, to recognize the importance of each parameter in optimizing surgical and rehab outcomes, to identify safe and effective rehab exercises targeting range of motion, muscle strength, and neuromuscular function. And lastly, but most important, is to understand the common mistakes and precautions that are to be taken by the patients while performing these exercises. Designing prehabilitation exercises requires a careful blend of mobility, muscle conditioning, and motor control. Range of motion, strength, and neuromuscular control form the foundation for restoring functional knee capacity before surgery or before return to play. These components work synergistically to minimize deficits caused by injury to optimize surgical outcomes. A structured approach ensures that joint mechanics, muscular performance, and movement quality are addressed simultaneously. So let's begin our discussion with range of motion. ROM, or range of motion, in simple words, means how much your knee joint can bend and how much can it straighten. A healthy knee normally goes from 0-degree extension to about 135-degree flexion. This movement is influenced by muscles, ligaments, cartilage, and the capsule of the joint. ROM is the foundation of every functional activity, from walking to climbing stairs to squatting. Without adequate ROM, even the strongest muscles cannot produce efficient or pain-free movement. This tells us why it is so important to focus on ROM before achieving complete muscle strength. Regaining full extension before surgery is critical. If a patient goes into surgery with a stiff knee, there are high risk of developing stiffness even afterwards. This is what we call arthrofibrosis, fibrotic tissue in the joint. Not just extension, but flexion is equally important, especially for activities like sitting, squatting, and climbing stairs. As mentioned before, ROM exercises improve circulation of synovial fluid. This fluid nourishes cartilage and promotes joint health. A patient who enters surgery with good range of motion tends to recover faster and has smoother rehabilitation process. Now, let's see what exercises can we do to improve the range of motion. To improve ROM safely, we focus on gentle, controlled drills. Heel slides are effective for improving flexion of the knee, while prone hangs help to restore full knee extension. Stationary cycling without any added resistance promotes joint mobility and circulation. Patellar mobilization prevents adhesion formation around the kneecap. All these exercises are pain-free, progressive, and safe to introduce even in the early stages of rehabilitation. Unfortunately, due to copyright issues, we cannot provide you with any link for any of these exercises. But you are free to Google them with these exact names and see how the exercises are performed. After discussing range of motion, let's now discuss muscle strength. Muscle strength refers to the muscle's ability to produce force. In knee prehab, the most important muscle groups are the quadriceps, the hamstrings, the glutes, and the calves. Strength is what stabilizes the knee during load bearing activities. If the muscles are weak, the joint becomes unstable, thus putting more stress on the ligaments and the cartilage. In fact, loss of quadriceps strength before surgery is one of the strongest predictors of poor long-term outcomes. Higher muscular strength have a protective function on the knee joint. Pre-op quadriceps and hamstring conditioning reduces post-op muscle loss and speeds up recovery. Stronger muscles absorb shock during landing or running exercises, thus reducing stress on the joint surface. Several studies show that the patients with better pre-op strength return to function earlier and have a lower risk of re-injury. Maintaining muscle bulk also lowers the chance of developing early osteoarthritis later in life. Let's discuss the exercises which are relatively safe while a patient is undergoing prehab. In prehab, we prioritize closed chain kinetic exercises because they put less shear force on the knee and hence provide more stability. Mini squats and leg press within a safe, pain-free range are excellent for quadriceps. Hamstrings can be strengthened with resistance band exercises. Glute bridges are critical for hip stability, and calf raises support the ankle-knee kinetic chain. The knee is a progressive overload. The key here is progressive overload. The patient should start with light exercises, ensure proper form, and progress gradually. Coming to the last component of our discussion today is the neuromuscular control. Now, neuromuscular control and strength are not the same. It is about how well your nervous system and muscles work together. It depends on proprioception, which is the joint's ability to sense position, and the reflexes that protect the knee from sudden stress. For example, when you land from a jump, the body automatically activates muscles to keep the knee stable, given if you have adequate muscle strength. After injury, this system is disrupted due to destruction of the proprioceptive receptors in the knee joint. Prehabilitation helps us to train this nervous system to restore the protective mechanism. Neuromuscular training improves how the knee reacts to sudden changes in direction or in load. Without it, athletes often develop faulty movement patterns, such as dynamic valgus collapse. By retraining balance, reflexes, and coordination, we improve movement efficiency and reduce the energy wastage. More importantly, neuromuscular control is one of the strongest protective factors against re-injury after surgery. This is why it is considered as a cornerstone of modern prehabilitation programs. Let's discuss the safe exercises that we can perform to enhance the neuromuscular control while prehabilitating a injured knee. To retrain neuromuscular control, we start with simple balance exercises like single leg standing on a firm surface. This not only improves proprioception and stability, but also builds confidence in the patient. Perturbation training is where the therapist gives the patient a gentle push. This helps to improve reactive control. Step up exercises train controlled movement and helps to realign the knee. Subsequently, balance boards or wobble disc exercises can be incorporated in the training program. This has to be performed under supervision of a therapist. All these drills are designed to challenge the nervous system safely without putting the knee at any additional risk. I always believe it is very important to know what a patient shouldn't do in a particular phase of rehab than what the patient should be doing. While exercises is essential, certain exercises or activities must be avoided at this stage. Open chain heavy quadriceps loading exercises such as heavy knee extensions places excessive shear stress on the ACL. This may cause re-injury of the ACL. High impact drills like jumping, pivoting, or cutting should be delayed until the later stages of rehab. Deep squats, especially beyond 90 degrees, may overload healing of the tissues, especially the meniscus. Most importantly, patients should never push through significant pain or swelling. Pain is a warning sign. Ignoring it can set back the prehab process. There is nothing called as normal pain or normal swelling. Now, to conclude, ROM, strength, and neuromuscular control are core pillars of the rehabilitation process. We primarily focus on these components before we move on to the next components in prehab. Each of this has a unique physiological and clinical importance, as we discuss in the lecture today. A structured rehab exercise ensures safety and progression. We avoid premature high stress to prevent setbacks to our prehab progression. These are some of the references that I have used today in my lecture. We'll be seeing you again in the next class. Thank you.